Today we will study about the dihydrogen, that is hydrogen. Hydrogen exists in two forms, that is ortho form and the para form. Ortho form, orthohydrogen having higher melting point and the para hydrogen having higher thermal conductivity. That means orthohydrogen having higher melting point, then obviously parahydrogen having lower melting point lower, and parahydrogen having higher thermal conductivity, then obviously orthohydrogen is lower thermal conductivity. At room temperature, 75% ortho and 25% parahydrogen exist. At room temperature, 75% orthohydrogen and 25% parahydrogen exist. And at 20 Kelvin, 99.82% parahydrogen form and the 0.18% orthohydrogen. In orthohydrogen, spins are in the same sense. Look at this, spins are in the same sense. Orthohydrogen having same spin sense and the parahydrogen have opposite spin sense. Laboratory preparation of dihydrogen: zinc plus dilute HCH2SO4 forms ZnSO4 plus H2 gas. ZnSO4. Zinc plus 2 mole of NaOH aqueous form 1 mole of Na2ZnO2. Aluminium plus NaOH plus H2O form NaAlO2 plus H2. This is the laboratory preparation of hydrogen. We will prepare dihydrogen when zinc is treated with the dilute H2SO4. Zinc sulfate and dihydrogen will produce. When zinc is treated with the sodium, 2 mole of NaOH, sodium zincate and the dihydrogen is formed. Aluminium is treated with NaOH in the presence of water, sodium alumate and the hydrogen will formed. Commercial production of dihydrogen by the process of electrolysis of water. 2 mole of H2O liquid electrolysis and we will get dihydrogen at cathode and the oxygen at anode. Okay. Electrolysis of brine, means aqueous NaCl. At cathode, reduction will occur, then +1 oxidation state of hydrogen becomes 0 oxidation state, and at anode oxidation will occur from -1 to 0 oxidation state. Okay, and aqueous NaOH is formed along in this reaction. Solution is basic in nature and pH increases. By the next method for the preparation of dihydrogen is by the action of steam on coke. By the action of steam means water in the vapor phase with the coke means carbon in the form of coke. At the temperature 1270 Kelvin in the presence of nickel, then we will get CO gas plus H2 gas, and CO gas and H2 gas commonly we called CO gas and H2 as a water gas or scene gas. We will call this as a water gas or the scene gas. Carbon monoxide plus H2O gas at the temperature 673 Kelvin in the presence of FeCrO4, CO2 gas and the H2 gas will formed. Carbon monoxide in the gaseous form plus water in the vapor form react in the presence of FeCrO4 at the temperature 673 Kelvin. We will got CO2 in the CO2 and the H2. Okay, and this reaction we called as water gas shift reaction. We call this as water gas shift reaction. Means from water gas or scene gas we get CO and we react once againly we react CO carbon monoxide with the water means steam in the presence of FeCrO4, then we will get CO2 and the H2. Okay, now we will study about the chemical properties, reaction with the metal ions and the metal oxide. We will study the chemical properties of dihydrogen and reaction with the metal ions and the metal oxide. Dihydrogen react with the metal and ions and the metal oxide, and the hydrogen in this hydrogen H2 act as reducing agent. Okay, then look at this, Pb2 plus H2 gas, we will form the Pb and the 2H plus. In this, hydrogen dihydrogen is in the 0 oxidation state, and here it is in the +1 oxidation state. And as it is a reducing agent, then it will go and oxidation, and those compound which undergo oxidation reduces other compound, and that's why we called it as reducing agent. Then it is then lead 2 plus, that is Pb2 plus, obviously it goes 0, that is reduction. Here dihydrogen reduces Pb2 plus to Pb0. Here dihydrogen act as reducing agent. In this reaction, dihydrogen plus copper oxide, and we will heat. Here copper oxide is in the +2 oxidation state, and here it is in the 0 oxidation state. Here copper undergo reduction, and here in next reaction dihydrogen react with the PbO and when we will heat lead, and the water will form. Here lead +2 oxidation state and undergo 0. Here is also reduction of lead oxide, here lead. Now with unsaturated hydrocarbon, we will react the dihydrogen with the unsaturated hydrocarbon. Okay, nickel, platinum, palladium heat, and we will get the alkanes. From unsaturated hydrocarbon, we can convert unsaturated hydrocarbon to the saturated hydrocarbon. That is saturated hydrocarbon, which means hydrocarbon having no any double or the triple bond. In this we can in other language we can also say that double and the triple bond is converted to the single bond. Okay, hydrogenation of the vegetable oil. Here vegetable oil plus H2, nickel 473 Kelvin, vegetable ghee will be formed. Hydroformylation of olefins to aldehyde. Hydroformylation H plus CHO and the olefins, that is alkenes. RCH double bond CH2 plus H2 plus CO, catalyst RCH2 plus CH2CHO, olefins to aldehyde. We can use hydrogen plus CO, that is scene gas. We can use scene gas for the formation of aldehyde from the olefins. Olefins we can say alkenes. From alkenes we can form aldehyde with the scene gas in the presence of some catalyst. Okay, and here is one carbon is increased in this process. Ionic and the saline hydrides. Ionic or saline hydrides, salt like, formed by the S block elements Na plus and the Cl minus. Lithium, beryllium, magnesium do not form ionic hydride. Ionic hydride, obviously it is formed by the S block elements, and there is an exception, that is lithium, beryllium and magnesium do not form ionic hydrides. That is BeH2 and MgH2 are polymeric in nature. These two compounds are polymeric in nature. Covalent or molecular hydrides formed by the P block elements. Okay, electron deficient hydride 13th group. Electron deficient hydride 13th group. Hydrides are electron deficient, electron precise 14th group, and the electron rich hydrides 15, 16 and the 17th group. Okay, metallic or non-stoichiometric or interstitial hydride formed by the D and the F block elements. From the 3rd group to the 12th group, hydride gap. Hydrogen does not react with the element of the 7, 8 and the 9th group. This is the important, that hydrogen does not react with the element of 7th, 8 and the 9th group, and we call these as hydrogen gap, hydride gap, because hydrogen does not react with the element of the 7th, 8th and the 9th group. Okay, non-stoichiometry, that is lanthanum LaH 2.87 and the YbH2 2.55. These are the non-stoichiometric hydrides, and it is formed by the F block elements, that is lithium and yttrium. Now we will study about the water, that is physical properties. Pure water is colorless, obviously, odorless and the tasteless. Water is present in the liquid state at room temperature. Obviously, water boils at 100 degrees Celsius and changes into the gaseous state, whereas it freezes at 0 degrees Celsius to form ice. Water molecules undergo extensive hydrogen bonding, that is one water molecules form 4 hydrogen bonding. It is somehow important, that is water molecules forms 4 hydrogen bonding. The existence of the hydrogen bonding is responsible for the high freezing point and the high boiling point, high value of specific heat, high latent heat of fusion, and the high latent heat of vaporization of water in the comparison to those of H2S and the H2SE. There is a 4 hydrogen bond in the water molecule, which is responsible for the high freezing point, high boiling point, high value of specific heat, high latent heat of fusion, high latent heat of vaporization of water in the comparison to those of H2S and the H2SE. The high heat of vaporization and the high heat and the heat capacity are responsible for the moderation of the climate and the body temperature of the living beings. High heat of vaporization and the heat capacity are responsible for the moderation of the climate and the body temperature of the living beings. Water having the high heat of vaporization and the high heat capacity, and which is responsible for the moderation of the climate changes, or the moderation means if we have a hot climate, then it water vapor makes them cooler, and the body temperature of the living beings. Now we will look at the structure of the water, that is oxygen and the hydrogen, and there is a two lone pair. Okay, and here is the 104.5 degree angle between the two hydrogen, and it is sp3 hybridization and the geotetrahedral structure of ice. And the structure of ice hota hai, structure of ice cage like structure, and the volume of ice is quite high. Structure of ice is cage like structure, and the volume of ice is quite high. That's why density is equal to mass by volume, and the volume is high. That's why ice has low density as compared to water. Okay, now density of water is maximum at 4 degrees Celsius. Density of water is maximum at 4 degrees Celsius. On moving from 0 degree to 4 degrees Celsius, cage like structure gets broken and the volume decrease, density increase. Okay, at 0 degree Celsius ice is formed, and on increasing from 0 degree Celsius to 4 degree Celsius, cage like structure break and volume decreases and the density increases. Okay, chemical properties of water. Amphoteric nature, water plus HCl, Cl minus, and the okay, as we know that the water is amphoteric nature, which makes us clear that water reacts with acid as well as react with the base. Here is example: if water react with the NCl, then it will go hydronium ion and the Cl minus, and if water is react with the base, it liberates OH minus and the ammonium ion. Okay, redox reaction involving water. Water act as oxidizing agent and as well as reducing agent. In this reaction, here water plus sodium, okay, which sodium is in the zero oxidation state, and the form sodium hydroxide plus H2. Okay, here water is in the +1 oxidation state and the sodium is in 0 oxidation state. Here sodium goes to +1 oxidation state, then it gets oxidation, and the water it gets 0. Then here what in water hydrogen gets reduced and the and act as water undergo reduction and the act as oxidizing agent, and sodium undergo oxidation. Water also act as reducing agent. Okay, here F2 is in the 0 oxidation state, and here F is in the -1 oxidation state. It undergo reduction, and here +1 water hydrogen is in the oxygen is in -2 oxidation state, and the here oxidation is in the 0 oxidation state, and therefore it will undergo oxidation. Okay, hydrolysis reaction. Water hydrolysis oxides and the halides of non-metal forming their acids. Water hydrolysis oxides and the halides of non-metals forming their acids. Okay, water undergo hydrolysis of oxides and halides of non-metals forming their acids. That here we can see that oxide of phosphorus P4O10 plus undergo reaction with the water, and it form the phosphoric acid. Here is sulfur trioxide and undergo reaction with the water, and it form their acid, sulfuric acid. Silicon tetrachloride undergo reaction with the water, and it form the SiO2 plus HCl. Water hydrolysis, carbides, hydrides, nitride, phosphide, and the some metal with the liberation of C2, H2, H2, NH3, and the PH3. Water hydrolysis, we can see the water hydrolysis of carbide, CaC2, and the calcium hydrides, and the nitrides, and the phosphides. Carbides form the C2H2, and the hydrides form the hydroxide. Nitride forms the nitrides form the hydride of nitrogen, and the phosphide form the hydride of the phosphorus. Okay. Hydrate formation. There are three main type of hydrates: compound in which water molecules are coordinated to the metal ion. Hydrate formation. There are the three main types of hydrates: compound in which the water molecules are coordinated to the metal ion. Here Cr, H2O, 6, 3 plus, 3Cl minus, Fe, H2O, 6, Cl3. In some compounds, water molecules occupies interstitial sites in the crystal lattice. BaCl2.2H2O, CaCl2.6H2O. Compound in which the water molecules are hydrogen bonded to certain oxygen containing anions. Example, copper sulfate .5H2O. 4 water molecules are coordinated to copper 2 plus ion, while the 5th hydrogen water molecule is hydrogen bonded to the sulfate ion. That is copper sulfate CuSO4 .5H2O can be written as Cu H2O 4 2 plus SO4 2 minus. Here we can written as